quantitative. Okay. Can you see the 26 number slide now? So we are on slide 26, that is quantitative data tabulation and presentation. So in previous session, we have learned about the qualitative data tabulation and presentation. So in this session, we are starting with this point and will come to the second unit in which we try to cover the measures of central tendency. So what is meaning of basically the quantitative data? Quantitative data means numerical data, right? So you have data in numbers with you and you're using it, the particular data, numerical data for your analysis. And that is the quantitative data analysis, okay? So what here expected is how you represent your quantitative data and how you present it, that we are learning in unit 1. So this is the remaining part from unit 1, but this is the basics before going further. So I'm explaining you. So if you are collecting a data on your own, you have the number of observations with you, right? So if you have the number of observations with you, which are limited in number, which you can directly use for your analysis, such type of a data we called as a raw data or series of observations, which we use as it is for the further analysis. So generally, the raw data or series of observations, when they are less in number, you can use it as it is. Such type of a data we call as a raw data. Okay, so number of students present in a class for a week. So these are the 6 days a week. School is 6 days a week. So 48 students on Monday, 47 on Tuesday, 50 on Wednesday, and so on. So you have the 6 observations: 48, 47, 50, 47, 48, and 46. So if you're interested in knowing the average students present in that week, so you can directly use the data and find out the average. So second example, height in centimeter of 5 students in a class. So height is continuous data, right? So you are measuring it, and number of students you're counting, so that kind of a data is a discrete. So any type of a data can be either it can be a discrete or continuous, you can use as it is. And whenever using data as it is, you're saying that the data is raw data, or you have a series of observations. So height of the 5 students in a class, so the height is given. If you want to find out the average height of 5 students, you can use the observations as it is. So when the individual observations are given, you are saying you are using a raw data or series of observations. So the second type is ungrouped frequency distribution. This is another way by which you can represent your data if your data is basically a discrete data. Okay, so the another name for this type of representation is ungrouped frequency distribution or discrete frequency distribution. Okay, so what type of a data and what type of representation it is? Here you have 2 columns in your table. When you represent your such type of a data or discrete data, generally in the table you want to show, that time you have a table like this, ungrouped frequency distribution table, in which you have 2 columns. In first column you have individual numbers, and in second column you have the frequency. So what it is actually, so if you have a data like this, if you have data like this, so this is the frequency basically. So what type of a data it is? Suppose we conduct a survey in which we ask 15 households how many pets they have in their home. The results are as follows. So we are finding how many pets are there in the houses, when we have conducted the survey for 15 houses. So you have 15 observations below. So there are 4 houses who answered that they have a 1 pet. There are 3 houses, they are saying they have 2 pets. 2 houses have 2 pets, 1 house has 1 pet. two houses has 5 pairs, one house is 6, 7, 8 means house with the number of houses with 6 pairs or 7 pairs or 8 pairs is just 1 in number. So how we represent it? We write down the number of pairs in first column and respective frequency in second column. So what your frequency is telling you how many times your observation is repeating in the data. Okay, so the frequency for the number 1 is 4. What is meaning of this? Your 1 is repeating 4 times in a data. Your number 2 is repeating 3 times in a data. Number 3 is repeating 2 times in a data. Number 4 is repeating just once. 5 is repeating 2 times. 6 is repeating once. 7 is repeating once. 8 is repeating once. So when you have data like this, so you have individual numbers in first column and respective frequency in second column, you are saying that your data is ungrouped frequency distribution type of a data. Or you can say it is a discrete frequency distribution too. So the next one is grouped frequency distribution. So here in this, you have individual numbers in the first column. So in grouped frequency distribution, you will have the group of numbers in the first column and respective frequency in the second column. So such type of data you are calling as a grouped frequency distribution. Okay. So if you have a data like this in which Alex measures the length of leaves on a oak tree to the nearest centimeter. So he's measuring the length of the leaf. Okay. So 9, 16, 13, 7, 8, 4, 18. These are the values in centimeter you have. So in order, the lengths are, so you are finding how many times the numbers are repeating here. So this is your raw data, right? So from 9 to 17 is your raw data. So now you arrange the data in order to make it into the table. So transfer it into the table. So in your data, 1 is repeating 3 times, 4 is repeating 2 times, then 5 is repeating 3 times, 6 is repeating 1, 7, then 8 is 3 times coming. So in this way, you have arranged the data in increasing order. Okay. So the smallest value is 1, the highest value is 18. The range of the data is 17 centimeter, the highest value minus the lowest value. So you have to decide the group size ultimately. So now calculate the approximate group size by dividing the range by how many groups you would like to make. So let's say you are interested in making 5 groups. So 5 the range is 17, right? So 17 divided by 5 you make. So 17 divided by 5, if you do, the answer is 3.4. So you can make a groups around 4, or you can make a groups of 3 numbers. So here I have made the groups of 4. The starting at 0 with the group size 4, we get 0, 4, 18, 12, 16 in the interval of 4. So write down the groups now. 0 to 3, 4 to 7, 8 to 11, 12 to 15, 16 to 19. So you are writing the frequency, respective numbers appearing in that particular group. So in 0 to 3, how many observations are there in 0 to 3? So just 3 observations, that is 1, 1, 1, right? So how many observations are in between 4 to 7? There are 4 to 7. So 2 times 4, 3 times 5, 6 and 7. So you are calculating the total number of observations, 1, 2, 3, 4, 5, 6, 7. So the frequency is 7 here. Okay, so in this way, we can write down the value for the values in the frequency table. So this is how we convert our data into grouped frequency distribution. Okay, so if the classes are not continuous, you have to make them continuous. Okay, though if these groups are not continuous, what is meaning of this? Groups are not continuous. Here, if you observe, if this is the group, okay, if this is the group, I'm talking about 0 to 3, then this is the lower limit, this is the upper limit for first group, you can say, or first first class. Then for the second class, you have two limits. This is the lower limit for the second class. This is the upper limit for the second class, right? So if these two units are same, these two numbers are same, means the upper limit for the previous class is same as the lower limit for the next class, then only we are saying that the classes are continuous. If they are not continuous, you have to take the average of these two numbers and you have to replace these two numbers by the average. So here, these classes are not continuous. So what we have done, we have taken the average. 3 plus 4 divided by 2 is 3.5. So I have written 3.5 at both the places. Okay. So similarly, you can do the calculations and you can convert your discontinuous classes into continuous classes. And these are the respective frequencies. So remember, always remember, what is the frequency? Frequency is number which tells you how many times your observations are coming in the data. So in this group, how many observations are coming in the data? Just one is coming 3 times, 4 to 7. 7 observations. In 8 to 11, there are 12 observations. So you can verify here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? 8 to 11, 12 observations. Then 12 to 15, 7 observations, 16 to 19, 9 observations. So total of the frequency is 38. So this is the frequency. We generally denote it by the small f, and we denote the summation of the frequency by capital F. So these are the standard notations in the statistics. Okay, so your capital N is total number of observations, that is summation of all the frequencies. So 3.5 will not come here because what is our look. Alex measured the length of the leaves on the oak tree to the nearest centimeter. So he's not, though he is doing the measuring it. So if the 3.5 is the length, he is either taking it as a 3 centimeter or 4 centimeter as per his pre-decided rules. He is doing it, and if the measurement is 3.5, he's either taking it as 3 or 4. So this is how we represent the numerical data. We represent it in 3 ways. The first one is we used as it is, that we called it as a raw data or individual series of observations. The second type, if your data is a discrete data, that time you can represent it in a ungrouped frequency distribution, where in first column you have individual numbers and in second column you have respective frequencies. And the third way is when your data is grouped or when your data is discrete or continuous, you can represent it in the grouped frequency distribution, in which you have the groups in the first column and respective frequency in the second column. So 3 ways: individual number of observations, second type, you have individual numbers in first column, respective frequency in the second column, or the third way, you have groups in the first column and respective frequency in the second column. So this is a histogram. So here the class intervals are given and frequency is given. So the classes are continuous: 10 to 15, 15 to 20, 20 to 25, 25 to 30, 30 to 35, 35 to 40, and respective frequencies are given. So for when you draw a histogram, if the classes are not continuous, the first thing you have to do is you have to make them continuous, and then only you can proceed. So how to draw a histogram? Histogram is basically a graphical representation of grouped frequency distribution. So here we have groups on x-axis and respective frequency on the y-axis. The bars are connected with each other. There is no gap between 2 bars, and such type of a representation we can do for the continuous frequency distribution. And this presentation we called as a histogram. Okay. So here the height of the bars are representing the respective frequency. So in 10 to 20, how many observations are there? By looking here, you can say 20 observations are lying in between 10 to 15. In 15 to 20, how many observations? 25 observations. In 20 to 25, 30 observations. In 25 to 30, 15 observations. In 30 to 35, there are 10 observations. 35 to 40, there are 5 observations. So by this way, by looking at the histogram, you can say what is the frequency for that particular group. So then we have a frequency polygon. And what is the difference between frequency histogram and frequency polygon? So basically, what is a polygon? Polygon is a figure which we can form in two-dimensional space by using a straight lines. Okay, so it is a closed figure. Any closed figure you are drawing by using a straight line is a polygon. So in this case, how we draw this? First, we draw the histogram. Okay, and as this is a histogram, then what we are doing, we are finding the midpoints of the of these groups. So we are finding the midpoints of this bars basically, and then we are joining this by the straight line. Assume that they are the straight lines. So we are joining by the straight line, and whatever the figure is formed is your frequency polygon, because it's a closed figure you have drawn using a straight line. Okay, so this is the frequency polygon. Then we have the frequency curve. In the same way, we are finding out the midpoints here. And when instead of joining by the straight line, when you join it by the curve, whatever you are getting is your frequency curve. So this is your frequency curve. So histogram represents dash dash series, individual series, discrete series, continuous series, stochastic series. Can you tell me the answer for this? Histogram represents individual observations. Can you represent individual observations? No. Discrete series? No. Continuous is the answer. A graphical representation of the frequency distribution is called stem and leaf plot, scatter diagram, histogram, or time series plot. It is a histogram, right? So here we are done with the unit 1. If you have any queries, you can mail me. So we are starting with the unit 2 now, and that is the measures of central tendency. So what are the measures of central tendency? Basically, measures of central tendency are the measures in which you are interested in finding a single observation which is representing your whole data. Okay, so measures of central tendency. So we have 3 measures basically: mean, mode, and median. So we try to finish all 3 measures in this session. So basically, it is a single value which is representing your data. Okay, so why this is important? Because it why there is importance of central tendency, measures of central tendency. It gives you a single value which is representing your data, which you can use for the comparison. The single value is available with you, so you can do the comparison between 2 data sets using that value, helpful in further statistical analysis. So we have 3 basically measures of central tendency, that is mean, mode, and median. And mean is the only measure of central tendency which we use for the further statistical analysis. So let's learn more about the mean. So this is the mean means basically I'm talking about the arithmetic mean. So it is, we also know this by the average. So whenever you are calculating average or saying mean, it is the arithmetic mean. Okay. So for ungrouped data or series of observations, so arithmetic mean, we generally represent it by the x bar. And the formula for this is summation of xi upon n. Summation of xi means sum of all the observations divided by the number of observations. So if you have ungrouped data or individual series of observations, that time you're using this formula. Okay, if you have individual observations, you are taking the summation of all the observations divided by the number of observations is your formula for finding out the mean in case of ungrouped data, or you can say individual series of observations or raw data. Okay, so the formula is x bar is equal to summation of x upon n. So this is the example. If you have these values, like a sample of 5 executives received the following bonus last year in $1,000, $1,000. So the first observation is $14,000, $15,000, $17,000, $16,000, and $15,000. And you are expected to find out the average bonus received. So what you are doing, you are taking sum of all the observations, dividing it by the number of observations. So sum of all the observations means 14 plus 15 plus 17 plus 16 plus 15, that is 77. And you have 5 number of observations. So 77 divided by 5 is 15.4. So your average bonus received is $15,400. So this is another example. Here also the individual observations are given. So you are using the same formula. Can you tell me the answer for this quickly? 7 observations. X bar is summation of all the observations divided by number of observations. So now we'll see how to find out the mean, basically the arithmetic mean in case of raw data, in case of ungrouped frequency distribution, and in case of group frequency distribution. Then we try to find out how to find out the mode for these 3 types of data which we can represent. 3 ways in which we can represent the data. Then we also try to find out the how to find out the mode for the all 3 data sets, 3 types of data sets, you can say. Yeah. So for continuous frequency distribution, your answer is, so if you are finding what is meaning of continuous frequency distribution? Continuous frequency distribution, it means you have the groups in the first column, group of numbers in the first column, or you can say the classes in the first column, and respective frequencies in the second column. So when such type of a data is given to you, number of students means the frequency is given. So it is expected to understand that this is the frequency, because how many students are scoring in between 0 to 10 is 4. So this is the frequency. So for such type of a data, the formula is summation of fi xi divided by summation of fi. So what is meaning of this? Or you can denote it by summation of fi xi divided by capital N. So summation of capital X, we denote it by the capital N generally. Arithmetic submission. So can you tell me what you want to want from me to explain again? Do you want to know how we have done the calculations for this? Bhagyalakshmi, kindly. Okay. So you have individual number of observations. So what is the formula you are using? Is summation of xi upon n. So what is meaning of this is your x bar and this is your arithmetic mean. Okay, so or average you can say. So basically when you have the observations given, we represent it like this is your x1, this is your x2. This is assumed that this is your x1, This is the random variable x3. This is x4. This is x5. This is your x6. And this is your x7. So you have 7 observations. So what is meaning of summation of xi means you're adding all the xi's. x1 plus x2 plus x3 plus x4 plus plus x5 plus x6 plus x7 divided by the number of observations 7. So if you do the total of this, all this is 295, I think, divided by 7. So it is, your answer is 42.1. Okay. Clear with this? Yeah. So if you have such type of a data, like you have the classes in the first column and you have the respective frequencies in the second column. Okay. So now what the formula we are using is this. Okay. Summation of Fi xi divided by summation of Fi, or your summation of Fi, you can denote it by the capital N. So I have done the calculations here. Formatting x bar is equal to your summation of Fi xi divided by summation of Fi, or Fi xi divided by capital N. Okay. So here you have classes. Values of xi's are not given, right? So what you are doing, you are finding the midpoint and you're considering your midpoints as your xi in case of grouped frequency distribution. When you have grouped here, which value to take as xi is the confusion. So what you are doing, you are finding out the mean for this. That is, you're finding the midpoint, and that value you are considering as your xi. So how to find out the midpoint here? Lower class limit plus upper class limit divided by 2. So 0 plus 10 divided by 2. That is 10 divided by 2 is 5. So the first value, this is your x1. So how to find out x2 now? 10 and 20 is given. So you are adding 10 plus 20 divided by 2. So 10 plus 20 is 30. 30 divided by 2 is your 15. So the third one, third class, 20 to 30. So 20 plus 30 divided by 2, that is 50 divided by 2, that is 25. For the fourth class, 30 to 40, 30 plus 40 divided by 2, that is 35. 40 to 50 plus 50 divided by 2, that is 45. 50 plus 60 divided by 2 is 55. 60 to 70 divided by 2 is 65. Now you have the values for x's, right? So these are the midpoints. When you have the observations like this, means you have the classes in the first column, you're finding out the midpoints first. Okay. The number of students frequency is given for the respective classes. So you are using it as it is. Okay. So this is your x. Then you are finding Fi into xi. That is, this is your x1, this is your f1. So you are multiplying it. 5 into 4, that is 20, you are writing here. 15 into 8, that is 120, you are writing here. 25 into 11, 275. 35 into 15 is 525. 45 into 12 is 540. 55 into 6 is 330. 65 into 2 is 130. So now you have the values for Fi xi. So you don't need individual values. What you need summation, right? This is the notation or sign for summation, means this is a sign for addition. Okay. So what you need addition of all this. So you are adding all the observations and the total is 1940. So now you get your numerator here 1940 divided by total number of frequencies. Total of the frequency is 58. So when you do it, this is your arithmetic mean for grouped frequency distribution. So this is how we do it. Okay. How the midpoint is the correct method means we generally try to, we don't know what is the distribution in between the group. So we are saying that and we get the closer answer without well. For comparison, if you want to do, or if you want the same answer in each of the calculation, that time you need some uniformity, right? So that's why this is how we do it. We use exercise as midpoint rather than taking any other value. So this is how we do it for the grouped frequency distribution. Clear with this? So now we move to the discrete distribution or ungrouped frequency distribution. So the formula is same. Your x bar is summation of fi xi divided by summation of fi. Okay, but in ungrouped frequency distribution, so 54 is summation of the frequencies. So what is your denominator here? In this formula, what is your numerator? Summation of fi xi, that is 1940. What is your denominator? Denominator is summation of frequencies. So where is the frequency column? It is here. The summation of the frequency is 58. So the same formula we use for the ungrouped frequency distribution. Okay. So here in this case, what type of data you have? You have the individual numbers in the first column and respective frequencies are given. So now you have exercise given. Okay, exercise given. You are using them as it is. When exercise are not given and you have the classes in the first column, that time only we are finding out the mid values. Here the exercise are given, so you are using them as it is. Some formatting problem is there. So what is the formula? X bar is summation of fi xi divided by capital N. So this x must be here. So this is x bar. X bar is summation of fi xi divided by capital N. So here what is given? Marks are given and number of students are given. So in first column, you have xi is given and respective frequency is already given. So 5, 15, 25, 35, 45, and 55. The frequencies are 20, 20, 30, 50, 40, and 30. What is meaning of this? There are 10 students who have scored 5 marks. There are 20 students who have scored 15 marks. 30 students have scored 25 marks. 50 students have scored 35 marks. 40 students have scored 45 marks and 30 students have scored 55 marks. So now here xi values are given. Fi is given. So you are directly finding out fi xi. So that is a multiplication of the numbers in the two columns. That is 5 into 10 is your 50. 5 into 10 is 50. 15 into 20 is 300. 25 into 30 is 750. 35 into 50 is 1750. 45 into 40 is 1800. 55 into 30 is 1650. So the total of this is your numerator, right? So what is the total? Fi xi divided by summation of fi. So what is your numerator here? The total is 6300. What is the total of the summation of the frequencies? It is 180. So your denominator is 180. Your answer is 35. So this is the formula for the combined mean. So I'm directly taking the example. Let's say you have the mean marks for 60 students in a section A is 40. The mean marks of 40 students in section B is 45. So mean marks are given. So let's say x1 is x1. So whenever you're finding out the basically arithmetic mean, so we denote it by x bar. Okay, so I'm taking here x1 bar and x2 bar as the means. Okay, so the values for x1 bar and x2 bar are given. So your x1 bar is basically, what is your x1 bar given? X1 bar is mean marks for 60 students in section A is 40. So mean marks 40. What is your x2 bar? Mean marks for the section B students is 45. So your x2 bar is 45. How many students are there in section A? Section A has number of students. N1 is equal to 60. And your N2 is equal to 40. Okay. So for 60 students, the mean is 40. For 40 students, the mean is 45. And if you want to find out the combined mean for the 100 students, how you do it? Simple way, you're finding x bar, that is n1 x1 bar plus n2 x2 bar divided by n1 plus n2. Okay, so what is your n1 here? 60 into 40 plus 40 into 45 divided by 100. So if you have one more section, if you have x3 bar here and n3 is given, you can do it like this: n1 x1 bar plus n2 x2 bar plus n3 x3 bar divided by n1 plus n2 plus n3. So this is the formula for combined mean. There is some problem with the formatting of these slides. I shall recheck before sharing your screen next time. Yeah, I can write the formula. So what is your x bar is generally n1 x1 bar plus your n2 x2 bar plus n3 x3 bar plus and so on up to nk xk bar divided by n1 plus n2 plus n3 plus and so on up to nk. This is the generalized formula. Yes, you need to remember this formula. So in final examination, this is all for your understanding. You will have just 1 marks questions for whatever the marking is like. I shall ask you to find out the simple arithmetic mean of 4 numbers or something, or find out the mean or median. The simple for raw data, I shall ask for the 1 mark. And in your final examination also, or in your assignments also, I shall give you one of the problem. Maybe any type of the representation of the numerical data, like I give you individual number of observations or grouped frequency distribution or ungrouped frequency distribution. Then you have to find out the mean, mode, median, standard deviation, and variance for the data. And on the basis of that and understanding of that table, you have to answer the multiple choice questions. Okay. So what is your MCMR is based on this topic. Basically, you have to do the calculations for mean, then mode, then median, standard deviation. You have to calculate the variance. And you need to understand the data, whatever the given data is. You need to, and on the basis of that, I shall ask you the simple questions, right? What is the arithmetic mean for the given data? How many students have scored out of marks? So you have to choose the two correct options. Like these questions I shall ask you in assignments also and in final exam also. So these are the characteristics of the arithmetic mean. So once, as we move further, I shall tell you from this particular topic of what type of questions I can frame for MCMR. So you will get idea how to prepare for those particular topics. Okay. So by looking at the LPP, how you can do the analysis, or correlation regression, we can have one MCMR case study. So this way we move further. Some of the important characteristics of arithmetic mean are, if you take a summation, the sum of the deviations in the individual items from the arithmetic mean is always 0. Okay, so this is X bar. What is meaning of this? If you have the 3 observations, let's say 1, 3, 4, 2, 3, 4. So these are the 3 observations. And if you're finding out the mean for this, so what is the mean? What is the X bar? So this is your X1, this is your X2, this is your X3, right? So what is your X bar here? 2 plus 3 plus 4 divided by 3. So what is the answer? 7. 9 by 3 divided, 9 by 3 is 3. So your X bar is 3, right? How the 3 is here? 2 plus 3 plus 4 divided by the number of observations, 3. So your answer is 3. So if you are taking deviations from mean, so if I'm finding out X1 minus X bar, X2 minus X bar, X3 minus X bar. So what is X1? 2 minus 3 is minus 1. X2 is 3 minus 3 is 0. 3 is 4 minus 3 is 1. And if you take a summation of this, it always comes 0. Okay, the sum of the squares of deviations of the individual atoms from the arithmetic mean is always minimum. So now if you are squaring it, if you are squaring, it means if you are finding X1 minus X bar square, X2 minus X bar square, X3 minus X bar square, and you are taking the addition. Okay, then it is always minimum. If you take a deviation from any other number, that is a more than whatever your calculation is. The arithmetic mean is based on all the atoms in the series. A change in the value of any atom will lead to the change in the value of the arithmetic mean. So if you change any of the value, your final answer will change. So this is all about arithmetic mean. So now we'll start with the median. So what is the median? Median is the middlemost observation. Median divides the data in 2 equal parts. So if you have number of observations, you are finding out the median. So it is the middlemost observation when you arrange your data in ascending order or descending order. So it is also known as a middle score or 50th percentile. So when you divide your whole data in, let's say, 100 equal parts, the 50th percentile means let me explain you. So let's so if this is your data, let's say, and you want to divide your data in 2 equal parts. So how many points you require to divide your data, which how many points will be there which will divide your data in 2 equal parts? Just 1 point is enough to divide the data in 2 equal parts, right? So if you have a data and you want to divide in 4 equal parts, okay, 4 equal parts. So you need to know about this 3 points. 3 points can divide a data in 4 equal parts. This is part 1. This is part this is your Q1, this is your Q2, and this is your Q3. So there are just 3 points which divide the data in 4 equal parts. This is your median. There is just 1 point required to divide the data in 2 equal parts. Similarly, if you want to divide your whole data in 10 equal parts. Let's say you have a pen with you, or you can say a candy with you. Okay, you want to divide it. So how many points you required? You just need 1 point. If you divide it there, it will get separated, right? In the same way, if you have data with you, if you want to divide your data into equal parts, you just need one number to know which will divide your data into equal parts, and that number is your median. So it is the middlemost observation. So when you are dividing in 2 equal parts, you're dealing with the median. When you are dividing your data in 4 equal parts, you're dealing with the quartiles. When you are dividing your data with 10 equal parts, you will need 9 points, and those are your deciles. Similarly, if you want to divide your data in 100 equal parts, you will need 99 percentiles, and the 50th percentile is your median. So here also, if you see, this part is equal to this part. So your Q2 is equal to median. So this is just for your understanding. Don't get confused here. So median is a point which divides your data in 2 equal parts. So what are the disadvantages of the median? It is not based on all the values. It is not capable of further mathematical treatment. In case of even number of values, it may not be the value from the data. So let's take example here. Let's say you have observations like 6, 9, 2, 3, and 5. So if these are the observations with you, first thing you have to do, you have to arrange your observations in the order. So the lowest one is 2, then 3, then 5, then 6, then 9. So if you want to find out the median, median means middlemost observation. Which observation is the middlemost observation? This observation, right? So below this and above this, same number of observations are there. So your median is 5 here. Right? So if how you can do this? How many observations you have? Let's say your capital N is number of observations is 5. So what you're doing, you're adding one more number to the 5. So you're finding N plus 1 by 2th observation. So 6 divided by 2 is 3rd observation when you arrange the data in increasing order or decreasing order. So we have arranged the data in increasing order. The third observation is, so N plus 1 means 5 plus 1 divided by 2th observation, that is 6 by 2th observation, that is 3rd observation, right? 3rd observation. So what is the 3rd observation? This is 1, 2, this is the 3rd one. So this is how we calculate the mean in case of odd number of observations. Okay, so if you have even number of observations, so I'm just adding one more number, or let's reduce the number. So if you have numbers like 2, 3, 5, and 6, and now you have to find out the mean. So in this case, whatever your mean is the arithmetic mean of 2 middle observations. That is 3 plus 5 divided by 2. That is 5 plus 3 is 8 divided by 2 is 4, but 4 is not observation here in the data. So this is what explained here in this point 3. In case of even number of values, it may not be the value from the data. Okay. So here, how to find out in such case, if you have even number of observations, your capital N is 4. Okay. So in this case, our formula is N by 2th observation plus N by 2 plus 1th observation divided by 2. So this is a separate example. Okay. So what is the N by 2th observation? 2nd observation, right? N is your 4. 4 by 2 means 2nd observation. plus n by 2 means 2 plus 1, that is third observation. Second observation plus third is observation divided by 2. Second observation is 3. Third observation is 5 divided by 2. Means 3 plus 5 divided by 2 is your median. That is, the median is 4. Right? N by 2 is 4 by 2th observation plus 4 by 2 plus 1th. So don't get confused here. You have to do this calculation first. Observation. So second plus third observation divided by 2 is your median. So I'm writing what is your second observation. 3, second observation is 3, third observation is 5 divided by 2. Your answer is 8 by 2 is 4. So let's see this in detail here. So the median is the median value of the sample when the data are ranked in order according to the size. So we see the median in detail in the next session. We'll start from the median. I shall again explain you what I have taught you here in case of median. So we are stopping here because of time constraint. Someone else want to take sessions on the same link. So we'll stopping here. We'll continue in the next session. So if you have any other doubts, you can mail me. I'm giving you my email ID. Also, I'm sharing a link with you. Kindly go to the link and share your feedback. I'm continuing from the median from the next session. So in the next session, we'll try to finish up with the median and mode. And if you are confused, you can go to your Swayam and you can see the pre-recorded sessions too. Thank you. Thank you for joining. See you in the next session. So this I've already